And we're back. Another day of the world's greatest class, also known as geometry. So today we're working on volume and density, day 1. Once again, as the common theme has been, very formula heavy, and you're given your state test reference sheet. So today with volumes and densities, we are going to be introduced to 5 formulas. And once again, these will be given to you on the test. So you just have to be able to identify, is it a prism, is it a cylinder, sphere, cone, or pyramid? So let's get right into it, starting off with these problems. This first one on the left, this green looking shape. Think of this as an ice cream cone. So then you go back and look at your formula sheet and you say, oh, there's something called a cone. This must be the shape. And the formula for a cone is 1/3 pi r squared h. Well, what do we know about pi r squared? Well, pi r squared is the area of a circle. So a cone is really the area of a circle times the height, and then we divide that by 3. So let's plug in our important numbers here. Our radius was given to us is 5. We square that, and then we times it by the height, which remember, height, again, is perpendicular, given by that perpendicular line there. It is not this 13 inches off to the side. It is not that hypotenuse there of 13 inches. So, once I go back in here and plug all of the appropriate numbers in, you end up with a volume of 314.159. So there was our cone one, pretty straightforward. Let's hop into our next shape. This shape is called a cylinder. And the equation for a cylinder would just be volume equals pi r squared times height. So once again, we're taking the area of this circle here, the base, and just multiplying it by the height. Now we don't have to divide this by 3, because if we thought about that cone, the cone has some sort of triangular shape that looks something like this. With a cylinder, we still have all of this area to account for. So that is why we do not have to divide by 3 here, because we have all of this red area still to account for. Okay, so let's go ahead and plug in our necessary measures. Now this one's a little tricky because we are given the diameter here is 3 yards. So I have to take half of that to find my radius, which would be 1.5 squared times my height is 4. So the volume here equals 28.27. And then our last problem, this ball shape here is called a sphere. And we look at our formula sheet. The formula for a sphere is 4/3 pi r cubed. So it's very, very important to pay attention to this cube here. Okay. Our radius is given to us, which is 8, and that is the only thing that you have to plug in. With a sphere, you just have to find the radius. And the volume here is 2,144.66. So plug and chug away your numbers for these volumes. So volume for a general prism, and we just call a prism some type of three-dimensional shape here. So like a rectangle that has been turned into 3 dimensions, and the volume again is the B, but notice it is big B, which stands for area of the base. It is not just base times height. We're dealing with three-dimensional shapes, so we would have to find the area of this base and then multiply it by your height. So the area of the base times the height. And we do area of the base because we want to take this sliver here and then multiply it by the height to be able to fill everything up inside of this prism. So we're taking this square shape, parallelogram shape base and multiplying it by 6 so we can fill everything up inside of this prism. Okay, so let's go ahead and jump right into it. So my area of the base would be 3 times 2, and then my height is just 6. So this turns out to be 6 times 6, so volume equals 36, and then now we're going to introduce our units. It is inches, and for volume you do cubed. So remember, area was squared, volume is cubed. So now we're given another prism here, and this is a triangle. So we want to find the area of this base first, and then we're going to multiply it by the height, which is 15. So recall, area of a triangle is 1/2 base times height. So my base, although it's not directly on that triangle, the dotted triangle, my base is still 30. So my base here is 30. And then this is a little tricky to see, but there's actually an arrow here that is pointing, saying that my height is 16. So I can go ahead and solve this triangle. The area of that triangle is 1/2. My base was 30. My height is 16. And then we multiply it by the height of our prism, which is 15. So when I multiply all of that together, I get 3,600. And then our units are feet cubed. All right, let's move right along into 2 sample state test questions. So the first one, what is the volume in cubic centimeters, which just means centimeters cubed, of this given pyramid? So I go back up and I look at my sheet and I say, am I given a pyramid? You bet I am. 1/3 big B times H. Remember, big B means area of the base. Now on a pyramid, the area of the base is actually a quadrilateral or a parallelogram. So the area down here, and in our case, this is 8 and 8, so we know this would be a square. So the area of big B would be 8 times 8, and then my height is given to us, which is 9, and we cannot forget that the formula says, well, we have to multiply everything by 1/3. So over here to the left, I'm going to write the formula for a pyramid, and then we just plugged in our appropriate numbers. So I'm just making some notes here for you to follow along with. But when we go ahead and solve this, we end up with 192 centimeters cubed. So hopefully if you see that on the state test, you're feeling pretty comfortable, you can ace it. Okay, another kind of real world problem here. We're given some type of capsule, and we want to determine the amount of a vitamin mix that we can put inside of this. So think of this like some sort of pill. We're putting vitamins inside of this, and we're told some stuff about the size. So it has a radius of 3 millimeters, and it has a length of 15 millimeters. So we have to cut this up a little bit and do some moving around. So if I took this capsule here and cut off the ends of both of this, well, this is a half sphere and this is a half sphere. So when I put those together, I can make a sphere. So the ends make a sphere. And the formula for a sphere, for the volume of a sphere, remember we're trying to pack vitamin mix inside of this. We want to see how much we can fill it up. That's what volume looks for. Is 4/3 pi r cubed. But we are told in the problem, hey, my radius is 3. So 4/3 pi 3 cubed. And that equals 113.097. So we have our sphere out of the way. I'm just going to do some cutting and moving. Lost part of my E there. Okay. So then our leftover middle part, remember, these ends are still a circle, and then we have this red kind of quick drawing. This is actually a cylinder. So the middle is a cylinder. And the volume for the cylinder, volume equals, that is pi r squared, remember the area of a circle, times the height of that cylinder. And our height was given to us as 15, but we have to cut this here. So if our radius was 3, given here, let me switch to a blue. Our radius is 3 here. That's what we were told. Well, remember, radius doesn't change. Radius is also 3 there. It's also 3 there. It's also 3 there. It's 3 all over these parts. Well, we want to focus in now on this radius right here. If that's 3, then that means that this radius is also 3. Same on the other side. This radius is 3, so that radius is 3. So we know that both of these measures have to be 3, which means this is no longer 15. This would have to be 9, so that when we add 3 plus 9 plus 3, then that gets us our 15. So the height of the cylinder is actually 9. So our radius remains 3, and height is 9. So the volume of that middle section equals 254.47. So we have to take our end pieces that made a sphere and our middle cylinder and add those together. So the total equals 113.097 plus 254.47. That equals 367.567. And our units were millimeters, so millimeters cubed, or just mm cubed for short.